Welcome back. In the last several videos, I described how monitor modules work, different types of monitor modules, and I explained those as interfaces between conventional devices and an addressable or intelligent fire alarm panel. But more specifically, it's an interface between the panel and conventional initiating devices. In other words, inputs to the system. In this video, I'm going to describe how control modules work. Control modules are interfaces between an addressable system and output devices, such as horn strobes, speakers, strobes, horns, etc. So in the top right, connected to the module, terminals T1 and T2, that's the data circuit, or the SLC. That would be connected in some form back to the panel on the SLC terminals. But more commonly it's going to be tied into another device, because you can imagine there's going to be several devices on that loop. So now on the output side, I'm just going to wire this up to some horn strobes pretty much the same way that all the initiating devices have been. So take a positive wire in and out of each one. There's positive, here's negative. And as we've talked about in the past, I have to go from one to the next. I couldn't have like a common terminal somewhere and then branch off to all the different devices, because then it wouldn't be supervised if I cut a wire, right? So at the end of the circuit, I'm still going to have my resistor the same way I have all along. So this is a pretty bad drawing, I apologize. But so we're going in and out of each one of these horn strobes. And in this case, the supervisory voltage, or the supervisory current that's flowing through this circuit and through the underlying resistor is excuse me, is taken from the data, right from the SLC. So it's a very low voltage, very little amount of current flowing. But when these devices have to come on, they're triggered through programming. So something in the programming, just like with all the other modules, I would set an address on this module. I would tell it this is address 8 maybe, so I'd leave 10s at 0, and I'd move the 1s to move the arrow to point at 8. And then in the program I would tell it, well, it's a control module. There'd be something called a type code, which I think we talked about a little bit. I could maybe tell it it's a speaker, I could tell it it's a bell circuit, whatever, and there's different characteristics that come along with each one of those, and that's something I'll probably get into more in the future. But basically, it's the current that's flowing through that circuit in a normal state, when that control module is not turned on, would be coming from the SLC. Once something in the program tells it to turn on, again, this is an output, so once an input turns on that is mapped to this device, now it's going to pass whatever the input to this control module, whatever the input power to this control module is. So in this case, if these are horn strobes, it's just going to be some sort of 24 volt power. So what we would need is some sort of external power supply, just like we did on the zone module. The field zone module, the FZM. So here I have an external power supply. There's a couple different options for where we would be getting this 24 volt power, but I'm not going to get into that right now. So the point of this is that this control module needs external power. It can't turn on 24 volt horn strobes with only data hooked up. So now it's got 24 volts power. Once something in programming tells this to go on, it's going to pass this input power to the output terminals, and it's going to power up the horn strobes. Now, as you know, we talked about horn circuits in the past, and I described how when they turn on, the polarity reverses. And the same thing is true with this. Even though it's a very small amount of current, if this says positive and negative, in a normal standby state, the current's going to, or the polarity is going to be reversed, so that even though it's not much power, there's the internal diodes inside of the horn strobes, as we talked about in the past, are preventing this from the horn strobe from even activating. If at 24, most of these horn strobes could run on 12 volts. So if you had a data circuit hooked up to it, even though there's not much power available, it's probably possible that they would maybe chirp a little or make some sort of noise, whatever. So the diode is blocking any current at all from passing through until that polarity reverses, and now it's taking this 24 volt power through and out to all these horn circuits. So as we know, everything in a fire alarm system has to be supervised, and we know that the module is going to be supervised because we're going to go into the program and tell it to pull or look for address 8. We're going to tell it it's a control module, so the panel is going to be constantly checking for module 8. So the data circuit is supervised in that way. If there were an open on this circuit, on the output circuit, it's going to show up as a trouble. Internally, this thing knows to supervise, to basically monitor the current on terminals 6 and 7 in the standby state. So if something happened to this wiring, it would go into trouble. It would say open circuit, module 8. But the power up here, that's a little bit tricky. In the old days, we would have to use a power supervision relay like we did for a 4-wire smoke detector, because this power terminal was not supervised in any way. And I think I'm going to draw that quickly. But the newer panels now, they have, with updated firmware, they know that based on the type code that you name this thing, if you tell it that it's, basically if you tell it it's a control module that's going to have like a strobe or something that should have 24 volts present at all times, it's going to supervise for that. And if that 24 volts disappears, you're going to get a trouble that says module 8 power loss or power monitor or something like that. But in the old days, you'd have to have, if you had several of these in a line, at the end of the line, you'd have to have the power supervision relay. So if I draw this and it doesn't make any sense to you, I would encourage you to go back and look at the 4-wire smoke detector video, because I get into it a little bit more in that video. So this is my drawing of the power supervision relay. And basically what we would do is we would take, this power goes into the module first, and then we're going to come down to this power supervision relay. And when the power supervision relay has 24 volts on it, those contacts close. So now it's got 24 volts. We're going to assume that this isn't faulty, so this switch should close. So now these two purple wires are basically one long wire. And we're going to need one more device now. We're going to need an extra point to monitor this. So I'm bringing a mini module into the picture. We'll wire this up with data quickly. So we go red to red, black to black. We're going to have to set an address for this and tell the panel that it exists and call it, the power supervision relay. Then we just connect the output side of it to one leg of this. The other side of it is going to go not all the way. We don't want to short this out, but we want to have a resistor in series. So what would happen is, basically this monitor at all times, as long as this device still has power, as long as nothing happens to the power circuit, the power supply doesn't fail, one of the wires doesn't come off, this monitor module is going to have the right amount of current flow. Excuse me, it's going to see the resistor using these contacts. So hopefully that makes sense. If it doesn't make sense, I would encourage you to go back and watch the 4-wire smoke detector video. And again, in new applications, you rarely have to do that because of the supervision on terminals 10 and 11 on the control module. It'll internally supervise that power, which, as you can imagine, saves a ton of time when you're setting these things up. In some cases, you don't have to pull an extra circuit. If you had like a strip mall application where there were control modules in every suite, at the end of every suite you'd have to have, at the end of that power run, you'd have to have these power supervision relays and monitor modules and everything else, and it's a pain. So the new application with the firmware is a pretty nice update. Looking at the time, I think that's where I'm going to stop this one. In the next video, I think I'm going to describe how the control module would work to turn on a speaker circuit. So in this case, in this application, we use horn strobes, and the next one we're going to look at speaker strobes. And it's very similar, but I think you'll see that the power is a little bit different because speakers don't work on 24 volt power. So I'll see you in the next video.